be the first team to put a road deck on a pier taller than an 80-story skyscraper. And pushing bridge building beyond anything attempted before, they plan to slide the entire 2.5-kilometer road deck over in 2 colossal pieces. The bridge's chief engineer, Jean-Marie Kremer, was one of the few people who believed it could be done.
All the engineers who know this method, who were in the know, didn't believe it was possible.
If the team had got their calculations wrong, the entire structure could collapse into the valley.
We found a solution for the construction, which was to launch the bridge from the 2 sides. One part on the Larzac Plateau, one on the Rouge Plateau. And to push them from the 2 sides, and to make them come and meet here, above the River Tarn.
Smaller bridges use a similar technique. A powerful set of hydraulic rams literally pumps the deck from one side to the other. But Millau would be the longest launch ever attempted over the highest piers in the world, and the results could spell disaster. The deck is so slender it would bend and collapse if it were pushed out over the 342-meter spans between each pier. The furthest anyone's previously managed is less than half that distance. The first part of the solution was simple. Fit a pylon so its cables support the front of the deck as it goes out over the valley. Then construct temporary steel support towers that halve the spans to a more manageable 171 meters. These steel towers were a construction feat in themselves. The largest, over 170 meters high, is the tallest ever built, and they needed to carry a massive load. 7,000 tons as the leading edge of the deck, together with the first 90-meter pylon slide over. Simply pushing this enormous weight over the top of the vulnerable piers would bring them crashing to the ground.
If we'd done a conventional launch, we would have knocked the piers over like the pins in a bowling alley.
So 2 of the team reinvent the way this type of bridge is built. Marc Boineau with Jean-Marie Kremer. The trick is to use a series of these launching systems to jack up the deck and inch it forward. Each system uses 2 wedge-shaped blocks under each side of the deck. The upper wedge is pulled forward by a hydraulic ram. It slides up the slope of the lower wedge at the same time, lifting the deck from its supports and advancing it 600 millimeters. The lower wedge then retracts, dropping the deck onto its supports. The upper wedge returns to its original position, and the whole cycle begins again. 4 of these clever devices are placed on each pier.